Hello, everyone. So here we are again on the neck journey, and I thought it would be useful to give a little history of my involvement with guitars and what led me to what many of you will perceive as a very complicated and demanding process that I use now. So there is a method, I believe, to the madness, and it starts with my involvement as a repairman in the 70s, when I was having fun figuring out how to optimize guitars that regular people owned and played. Here's a good example of something that I might have gotten. Well, I guess it would have said Fender up there, but at any rate, something I would have been working on. And what I found was that as a result of the manufacturing processes used in making these splendid Fender products, that there were issues with the neck bending here, as we've discussed, and so I had to straighten out a lot of guitars as a result. It was very informative, interesting work for me. I got to use my training as a machinist and bring some of the accuracy of metalwork to my fretwork, and in terms of measuring and setting standards and quality tolerances for my work. Anyhow, so at the same time, I was building Archtop guitars, and I was trying to solve the neck production problems by using perfect material, vertical grain material for all the components of the necks. This was a little truss rod adjustment detail that I used for a while, so that I didn't need a cover. I just created a pretty opening that didn't need covering up. And, this was my little young man show-off move, inlaying my signature in mother of pearl. As I learned more about instrument making, I was able to try and fulfill some wishes from my customers that were new kind of demands. This is the first neck that I ever built for an Archtop guitar designed to be strung up with nylon strings. This is from 1980. This is my first everybody on one side headstock. Before that, I was making 3-and-3 headstocks like everybody else. And I'm going to explain that to you, and when maybe for right now, as a placeholder, we'll just call it that Floyd Rose taught me that 3-and-3 is inferior to everybody on one side, but that's a story for another day. Okay, so this is 1980. Then I got involved with my wonderful pal Larry Fishman in the early 80s. And we started working with composite material. First was, and I don't have any of them to show you right now, but I was building basses, long scale basses with 6 strings mostly in the early 80s. I was working with Anthony Jackson, trying to get him happy with the performance of an instrument, and some other wonderful bass players in the New York area active at the time. So this project, which turned into the Fly guitar, was a spin-off of making basses. And the reason that basses were difficult to make was that I had to make all the hardware. I had to make the bridges and sometimes modify the tuning pegs. And I thought it would be just cheaper and easier to do my prototyping on a guitar. The downside of that, of course, is that unlike bass players, guitar players are resistant to change. Bass players just want to sound good. Guitar players want a guitar that sounds like a Strat and a Les Paul together somehow. So in other words, they had unreasonable expectations and unrealizable goals. We all found out in the 70s as we tried to fulfill those wishes. When I got involved with veneering the necks the way the lute makers taught us to do, I used wood veneer. I veneered the backs of these long scale bases I was making with, well, some kind of veneer, either hardwood like maple or sometimes ebony. And so I was able to veneer the backs of 6-string bass necks with ebony, quite a project. So I reached out into the composite world and trying to figure out how I could use advanced composites, that is high strength fibers, carbon mostly, and high strength resins to achieve the goals that I was trying to do by veneering with wood. Anyhow, this is the first fly guitar, and this is the original fingerboard for the first fly guitar. And so I know a couple of people have asked me online why the guitar is called the Fly. And it's because the day I was building this guitar, Larry Fishman had come down to my shop, which was in my grandfather's basement in Connecticut. And he had brought with him some kind of industrial paper, and it was a German no-pest strip. And this was the packaging material for the German no-pest strip, so the text was in German. And it was an interesting material. And so we had some of it because it was aluminum and paper and mylar laminate. So anyway, that's what this is. And while I was off in my little machine room playing around making something on the Hammond saw, Larry cut out this thing and stuck it on there, and we had a laugh, and it was the Fly guitar ever after. So that's the origin story of the Fly. All right, back to the fret and fingerboard system. So this was the first fingerboard that I made with glued-on frets. You can see that there's some kind of adhesive something or other, these blue things. And then the frets on this guitar were a piece of 3/32 or a 93 thousandths diameter brass tubing. And I just cut the brass tubing in half on my surface grinder, ground away half of it. And then Larry and I glued these frets on together. This is a heat-activated adhesive. And I remember that we were gluing them on, trying to hold them down with our fingers or the end of an eraser or something, and getting burned and having a heck of a good time doing it. Anyway, so I think we quit at whatever it was, maybe 12 frets. We were tired of burning our fingers, and we put it together, and it worked. And so everything else came from this guitar. So this was reinforced with carbon and glass, and it's such a mess because my only vacuum pump caught fire in the middle of this operation, and so I had to just kind of make do with repair techniques and filler. But anyhow, it worked, and that was our first Fly guitar. We learned a lot from this instrument. Hard brass tubing was not the correct material for a good fret, and I reached out to a company that made cotter pins, and a nice guy was happy to just send me as a sample a whole bunch of cotter pin wire. And so this is kind of a D-shaped cross-section. In other words, a regular fret without the tang. So that's what I wanted. And I was able to do quite a lot of prototyping on guitars in the mid-'80s with this cotter pin material. That's what these are, I believe. And the way that worked was I would laminate a piece of carbon fiber, unidirectional carbon fiber, and on top of that would be a piece of fiberglass cloth that's with dyed black resin in it. If you look over here, you can see here is a guitar covered with the same exact cloth. This is 2.5 of a millimeter, 0.25 millimeters, or 10 thousandths thick. Here's the same material with black dye in the resin, and then this is just the glass without the dye. And you can see the carbon fiber is in the same position on both of these instruments. Back to the fingerboard. This was 20 thousandths or 0.5 millimeters thick. We made thousands of these, and we glued on these frets with a methyl acrylic adhesive. Partly we used it because, apart from it being pretty strong and resistant to chemicals, it was possible to clean up the squeeze out, which we never found an epoxy that we could do that on. But we used an acrylic adhesive. And it made this kind of amazing structure that would conform, as you can see, to whatever surface we created. We created a perfect surface for this to glue on, and the result was we were able to transfer the perfect surface through this perfectly flat, equally thick piece of composite material, and then, very closely controlled the heights of the frets so that we could transfer our machined surface on these production guitars right to the top of the frets and therefore not have to do any fretwork. So the reason that I was trying to design a guitar that didn't need fretwork was that I had worked on so many of these things made by our favorite heroic guitar companies, American guitar companies, that were doing presumably the best job they knew how to do. And a lot of these needed repair. So I decided it was time for a better mousetrap, and this is what I came up with. We got a patent on this and went ahead to make thousands of guitars with those methods, using something like this, something like half a cotter pin as a fret, okay? And then this is a guitar that was a one-off from, 1986, I think. This one weighs just about 2.3 pounds, or just slightly north of a kilogram. It's made all out of Douglas fir with a little bit of carbon fiber and epoxy on the back. And it's a really fun guitar and sounds good. Big sounding guitar. So sometimes less is more. All right, so this is kind of the quick story on the whole Fly project. Before I was making fingerboards like this, I experimented with plastic and phenolic materials. This is a paper phenolic fingerboard from way back then in the early 80s. And well, I guess one of the problems with these was that even though it has, quite a bit of stiffness when it, it might not look like it, but it's pretty strong when you glue it to a neck. Unfortunately, the thermal coefficient of this is pretty big, so changes in temperature would actually change the shape of the neck. The length of this piece of material would grow as it warmed up and then push the neck backwards. And then also, if it got cold, it would let the neck come forward. So that was kind of a problem. Set that experiment aside. And then just for fun, I'll show you my first tool for gluing the frets precisely to the fretboard. And the way this worked was I did a perfect fret job on this chunk of mahogany, and then I made a mating piece and then cast the positions of the fret slots with epoxy. So when I put it all together, I could put the frets in here with the adhesive on them, and then on this piece, here's a locating pin. On this piece, I'd put the fret board that had little sandblasted places for the frets to glue. And so this would line everything up. There was a pin at each end here. And so that would line up the frets and the slots in the fingerboard that were sandblasted in order to improve adhesion. Anyway, the whole thing went together like that somehow. And I was able to make some pretty nice fingerboards from this simple mahogany tool. It's just how life is. Sometimes a simple mahogany tool will get you down the road. This is kind of an origin story for me. It's part of my neck journey, trying to say, why do we have defects in high-quality production instruments that stop the player's ability to use the instrument? And then how do we maybe solve that by creating a more stable structure that isn't subject to some of the problems that a regular neck is subject to? Again, the guitar necks were doing fine until we put steel strings on them and asked them to be very accurate. And then problems showed up with the distortions and creep, which we've explored already. So this was my evolution of understanding and experimenting to try and figure out how to make a reliable instrument that didn't need fretwork, let alone fret jobs, as they aged, and they could continue to be of good service to the musicians that were depending on them. Origin.